Okay, let's go through the next one. So again, very similar format to this question. It's saying find the derivative of this and hence evaluate the antiderivative of this. So again, it's an integration by recognition question. And you know, one of the nice things about these questions is that it kind of gives you, well, something close to the answer at least when you read the question. So, you know, we know that's what we're working towards. Now, to differentiate this, I've got a function divided by a function, so I need to use the quotient rule. So I'm just going to write that down. dy dx is equal to v du dx minus u dv dx, and then divide it all by v squared. Now in this case, u is equal to cos x, and v is equal to sin x. So when we differentiate these, du dx should be negative sin x, and dv dx should just be cos x. The next thing is I need to sub these back into the rule. So I've got v times du dx, so it's sin x times negative sin x, which is negative sin squared x, minus u times dv dx, which is minus cos squared x. And that's all divided by v squared, which is sin squared x. Now, a little bit of the trig identity, or the Pythagorean identity coming in here, because what I can do, I've been a little bit lazy there, I should be writing dy dx is equal to that, which is equal to negative 1 out the front of sin squared x plus cos squared x, and then divide all of that by sin squared x. So that's sin squared x plus cos squared x. We know that's just equal to 1 from the Pythagorean identity. So it's negative 1 times 1, which is just negative 1 divided by sin squared x. So we've got the derivative there. Now again, what that means is that when we anti-differentiate this, we're going to go back to the original function that we had right back at the start. So I therefore know that the antiderivative of negative 1 over sin squared x with respect to x is equal to the original function cos x over sin x. Now, I could write the plus c and all that sort of thing, but this here had terminals. The terminals were pi on 4 and pi on 2. So I'm going to add those in. And when we anti-differentiate, I know that I just need to do that between pi on 4 and pi on 2. And I know that because a definite integral, the constant term is going to cancel out. Now the other thing that I need to consider here is the fact that there's a negative sign, which we don't want a negative sign when we are working on this part here. So I need to move that negative sign over to the other side. Okay, I could just take it out the front and then divide by negative 1 on both sides, or you could just divide by negative 1 right away and, you know, get the same answer. So lastly, the antiderivative between pi on 4 and pi on 2 of 1 over sin squared x dx is equal to negative out the front of cos x over sin x between pi on 4 and pi on 2. And lastly, I just need to sub those values in. So that is negative out the front of cos of pi on 2 over sine of pi on 2. And I'm going to minus cos of pi on 4 over sine of pi on 4. I'm not going to quite finish this video, this question in the video here, but I will follow it up in the next one, and we've got a little bit more to go through yet. See you then.